My screen is visible.
Yes, sir.
Yes. Okay. Today we will learn disk partitioning and LVM. In last class, we have discussed about some important directories in Linux and what is absolute path, what is relative path, and how to change a directory, how to list the contents of a directory, and how to copy files and directories in Linux. So today we will discuss how to partitioning a directory. Yesterday also I have told you how to identify what is a disk, that means what is a hard disk and what is a external hard disk and what is a partition. How we can identify this, I have already told you. SDA, SDB, these are the hard disks, and SDA1, SDA2, SDC, SDA3, these are the partitions. By seeing this combination, we can identify this is a partition and this is a hard disk. Also, we can identify seeing the SDA, SDB as an external hard disk. By seeing the HDA, we can identify this is a external hard disk. So now we will discuss what is a firmware. Firmware comes in two ways. One is EFI and another is BIOS. EFI means extensible firmware interface uses GUID partition table. That means EFI supports the GPT partition table, and whereas BIOS supports the MBR partition table. Now all servers are coming with EFI partition, which supports the GPT partition. So both UEFI full software that starts when you boot your server before booting your operating system. That means when we will start a server, before server starts the operating system, BIOS starts, and that BIOS may be UEFI or a BIOS. BIOS are two types. By default, Red Hat Enterprise Linux or CentOS comes with the GPT kernel support. UEFI is more modern solution supporting larger hard drives, faster boot times. UEFI firmware still referred to as BIOS to avoid confusion. That means BIOS are two types. That means BIOS is a very light software which is UEFI or a BIOS. Still we are calling UEFI as a BIOS because to avoid the confusion. BIOS cannot create a Linux partition larger than 2 TB using the fdisk command. That means using fdisk command, we can create a partition, but in case of BIOS, we cannot create a larger partition more than 2 TB. So command will be fdisk /deb sdb. Here /deb sdb is the hard disk, and using the fdisk command, we can make a partition. To solve this problem, GNU parted command that with GPT, that means parted /deb/sdb. Using the parted command, we can create GPT partitions more than 2 TB as a single volume. For this partitioning, we have to use the command fdisk. Let me show you. Fdisk -l is the command which will show you the detailed about the hard disk and the partitions. So here SDB and SDA having two. I have added two volumes in my Linux operating system having 2 GB capacity. So let's make a partition from the SDA volume. So command will be fdisk/deb/SDA. Here you can see welcome to fdisk. Changes will remain in memory only until you decide to write them. That means after complete the partition, we have to save them. So here enter M for help. You can see these are the options we can use here. D for delete and N for add a new partition. So P the print the partition table. Here if I use the P, you can see there is no partition already created. So now we will create a partition. Here is the chance also how to decide if we will create a GPT or a BIOS DOS partition. That means for GPT we can use the G, and for DOS we have used the O. Let's use the G only. You can see now the GPT partition should be created using this volume. Let's again use the N. Then here it will ask the number of partition. Please press here 1 here. That means default will be 1. It will create a partition having number 1. Then first sector, please enter here. Then use the last sector. As I will create a single partition using 2 GB, so I will utilize the all the spaces starting from 2048 to end number. You can see /db SDA1 is created with Linux partition type. So we need to use the W here so that it will be save the partition. Now check again with the fdisk command. You can see SDA1 is created. That means one partition is created from the /db SDA volume. Is it clear to all? Okay. Likewise also,
Yes,
we
sir.
can create another volume, create another partition from the /db SDB. You can see SDA1 and SDB1 is created. That means two volumes or two partitions are created from the two volumes. Now you can format /db/sdb1 and mount it as usual. That means now we have to format the new created partition according to our requirement. We can use it as a MKFS partition, or we can make as a ext4 partition. According to our requirement, we can use that. But I have already told you, in case of ext4, we can, if we configure the LVM, then we can extend and reduce as well. But in case of XFS, we cannot reduce the partition. So we will use the MKFS partition format. We will format the partition in a ext4 format. mkfs.ext4/deb/sdb1. Again also we will format the SDA1. The next step is, we also know that df-h command will be show the all the mounted partitions. Here you can see we have created two partitions, but that partition is not showing here. That means another step is pending. We have to mount that partition. How we will mount that? We will create a directory, then we will mount the partition.
Hello, sir. Video कटिगला.
We have created data 1 and data 2. Then we will mount the partition. mount command will be mount dv slash sda1 slash then again mount the data 2 with the partition sdb1. Now use again the command df minus h. You can see two partitions are now showing here. But this is the temporary solution. Whenever we will restart the reboot the server, then this partition will disappear and this will be not available for the use. So to make it permanent, we have to make an entry in slash fstab slash etc slash fstab. Here we have to make an entry slash dv slash sda1, then one space slash data data 1, then slash ext4, then partition, then defaultsd false, then 0 space 0 again, and slash dv slash sdb1 slash data data 2 ext4 defaults 0 space 0. Now save the file or save the configuration. Then again check using the mount-a command. You can see there is no error. Please remember this, once make a entry in fs tab, we have to check the configuration using the mount-a command. Else here if there is any error in the entry in the fs tab, it will be display here. Unless until what will happen if we will make a entry in fs tab and we will not check and we will reboot the server, then server will not come up with the control D error. At that time server will not come properly. So it is necessary to check the entry in fs tab using the command mount-a. Let me show you. Here we will do a mistake. That means we will remove the s here and we will save the entry. You can see in the configuration of sdb1 we have here is a wrong entry in slash sdb partition. I can quit, then check with the mount-a command. Let me unmount that partition. So we have already mounted. Now you can see it is showing that for slash data to wrong fs type bad option. That means here is a wrong entry for slash data 2 and here we will be correct that one. You can also see that data 1 for parameters for data 1 is correct. That's why data 1 is mounted, but data 2 was not mounted with the error. Again we will use the same command mount-a. You can see there is no error and check the partition. You can see both partition are came and configuration is good. So please remember this one, after making the entry in fs tab, it is always advisable to check with the mount-a command, else the server will not come up and it will show the control D error. Is it clear to all?
Yes, yes.
Yes, sir. Yes, sir.
Okay, great. Then now we will learn the LVM. What is LVM? LVM is logical volume manager. That means we will logically manage the volume. So what we will do? These are the physical volumes. These are the multiple physical volumes. Out of the physical volume, we will create the partitions. Then using those partitions, we will create a volume group. My screen is visible to all?
Yes, sir.
Okay. So using the partitions, we will create the From the volume group, we will create the logical volume and mount the logical volume to the directory according to our requirement. So now we have created two partitions. You can see we have already created two partitions, SDA1 and SDB1. We will configure the LVM using the SDA1 SDB1. So for that we have completed this person only. We have taken the two physical volumes and we have also created the partitions. Now we will configure the volume group. To create the volume group, first we have to use the PV create. That means we will prepare the volumes, we will prepare the partitions for the logical LVM. PV create PV create /dv /sda1 we cannot open the mounted file system. Okay, -h we have already mounted this one. So unmount the partitions. As well as comment the entry in FS tab. Check the entry using mount-a command. I can see commented in FS tab. Now we will use the PV create. Yes. Then we will use the SDB1. That means we are prepare the SDA1 and SDB1 for the logical volume. So here we have successfully created the PV, prepare the physical volume using PV create command. To check the physical volumes in LVM, use the command PVS. That means physical volumes. As you can see, two volumes we have used for the LVM, SDA1 and SDB1. So here PVS, you can also use the PV scan and we can also use the PV scan command as well in case of PVS also. So then we will create the logical volume. So PV display also another command. PV display, PVS and PV scan. Three commands you can use to display the physical volumes. Now we will create the logical volume using, now we will create the volume group. Here we have created the physical volume. Now we will create the volume group using the command vg create. Vg create mime_vg. That means mime_vg is the volume group and SDB1, SDC1. In our case, we will take the SDA1. Now we will use the command vgs to check the volume group. Yes, you can see. You can see we have used a wrong command. That's why volume group not created. We have used a hash here. That's why command was wrong. Again use the command vg create.
Hello.
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 Yes, Surya, please tell me.
Sir, I think there is a wrong my VG, sir, why VG create a my VG slash dev slash SDB1 and SDB1, sir. Why this command we are type? Sir, explain again,
Uh,
sir.
okay. Actually, here is 3 steps we have to follow. First, we have to use the PV create. This will prepare the volumes for the LVM. Then we have to create a volume group. Let me show you. Actually, here I believe there is a little bit confusion in your mind. You can see here, these are the physical volumes having different size. Okay, we will group them and create a logical volume. Now these are the individual units. Now we will configure them such a way that they will display as a single volume having 200 GB. But these are the multiple volumes having different size. This is the thing what we have created here. We have created the volume group. That means we have taken the two volumes having 2 GB and created the volume group myVG. This is the myVG. Please use the command here VGS. You can see myVG is created having 4 GB. So using the SDA1 and SDB volume group, likewise I show here. Here these are the different volumes having different size, and we have created a volume group having 200 GB. Then out of this group we will create a logical volume 100 GB. This is the example. So we have already created the logical volume. This is the volume group. Out of this volume group we will create a logical volume. Is it clear to you? So myVG is
Yes,
only
sir.
the
Yes,
name.
sir. Oh, okay, sir. The volume group name, sir. Right?
Yeah, myVG is the volume group name.
Clear, sir. Clear.
You can see previously I have also logical volume. Sorry, I have also another logic LVM group, that is RHL. Now we have created myVG. So now we will create a logical volume using the command lv create from the group mylv. Here it will myVG. Yes, logical lv create minus n means new, mylv means it will be new volume mylv, minus l means length will be 2 GB from the myVG. Using myVG, we will create a new partition, new volume having 2 GB capacity, and the name will be mylv. You can see LVS, you will create the command LVS. You can see mylv, a logical volume created from the myVG, volume group is myVG and having the 2 GB capacity. So likewise, you can create a logical volume from the volume group. Previously, we have created a volume group myVG. From out of the volume group, we will create multiple volumes, logical volumes, and it is also possible to reduce the logical volume, also expand the logical volume. According to our requirement, you can reduce it as well as expand it. Now, next step is we have to again format the logical volume. Here we will, if we will use the XFS, we cannot reduce the partition. If we will use the ext4, we can reduce as well as expand the volume. You can see now volume is formatted with ext4 partition. Sorry, ext4 format. Now again we have to mount the volume. We will mount it with slash data. Then you can see using the df minus h command, the volume is mounted with slash data. To make it permanent, again we have to make an entry in slash etc fs tab. Copy this path, then use the mount -a command to check the fs tab entry, then df minus th. You can see data is mounted with the logical volume mylv and the partition format is ext4. Is it clear to all?
Yes, sir.
Okay, we have completed today's session. Today we have learned how to make a partition from the physical volume, and also we have learned how to configure the LVM. Anyone having any doubt, please ask me.
Sir, I have a one question, sir.
Okay, please tell me.
Sir, when and why we are use def slash mapper in fstab entry?
This thing we are asking, why we will use the DB happen mapper.
De yes, sir. Yes, sir.
So actually, whenever we are creating a volume group, then it is created likewise. Whenever we have directly make partition, at that time you can see that previously slash db and sda1, sdb2, but in case of logical volume, this will be create like this slash db and slash mapper. Then this is the my vg is the volume group and my volume group and my lv is the logical volume. Likewise, this will be created. In case of logical volume,
Okay, sir.
this will be added with the volume. This is also LVM. This partition is also created from the LVM. That's why here slash db mapper added. You can see using the command lvs, you can check root, swap, and mylv. These are the three logical volumes are present. So RHL-root, mylv, and swap also. Swap is not showing here. Okay. RHL is the volume group and root is the logical volume. You can see here RHL is the volume group and root is the logical volume. Likewise, myVG is the volume group, mylv is the logical volume. So the format will be like this, DV mapper. Is it clear to all?
Yes, sir.